of x is x plus 2 over x minus 4, so I put that inside the parentheses. That says go to the function g, wherever we see x, plug in that quantity. So there's the function g. Wherever I've got x, I'm going to plug in that quantity. So what's the least common denominator?
X minus 4.
X minus 4. So we'll multiply every term by x minus 4. Numerator, first term, what do we get? X plus 2 plus
X minus 4.
x minus 4. Denominator? 2x plus 4 minus
3x.
3x plus 12. That's 2x minus 2 over negative x plus 16. Once again, notice they are not the same. What's the domain of G composed with F? X cannot equal what?
4.
16 or
4.
4. So it's not just the final answer that we look at for the domain, it's any fractions that appear in the problem. I want to do one last thing here to finish up tonight. There's a point in calculus where it is important that you be able to go backwards and undo composition. Let's not call it decomposing because that's kind of disgusting. But let's call it uncomposing. You want to uncompose a function. I'm going to start with, I'm going to say this is an easy one, but I actually think the second one I'm going to do is a lot easier. Capital F of x is the function absolute value of x plus 4. And I'm going to tell you that I formed this function capital F of x by composing together two little functions. So it was found by finding f composed with g. What is f of x? And what is g of x? So what two functions did I compose together to get the absolute value of x plus 4? F composed with g by definition is f of g of x. When I used to teach this in a business calculus class, at this point I would say, we're going to call g of x the inside function. It's inside the parentheses. Go back to that function. What's the inside function? What's inside the grouping symbols or whatever? X plus 4, g of x is x plus 4. F is the outside function. Once I found x plus 4, what's on the outside? Absolute value, f of x, is the absolute value of x. If I substitute this in for x, do I get that big F function? If I substitute this in for x, yes I do. This one is going to look absolutely horrible, but to me it's actually easier than what I just did there. Capital F of x is formed by composing together f and g. Capital F of x looks like this. 17 times the quantity 2x squared plus 3x minus 1 cubed, plus 9 times the quantity 2x squared plus 3x minus 1 squared, minus 4 times the quantity 2x squared plus 3x minus 1, plus 5. Please believe me when I tell you, you do not want to multiply this all out. I want to know what function is little f and what function is little g. So little f of x is what? And little g of x. So I said f composed with g is f of g of x. So g of x is the inside function. G of x is the inside function.
2x.
What's inside here? 2x squared plus 3x minus 1. So let's call it that quantity. Once I have that quantity figured out, what's f of x? What's the outside function? So 17 times x cubed plus 9 times x squared minus 4 times x plus 5. If I take that quantity and substitute it in for x, do I get this big function? Yes, I do. When we use this property in calculus, it's called the chain rule. Remember I said composition is just like chaining two functions together. This is really unchaining.